Hi, welcome and thanks for tuning in to this session and joining us in the IoT track today. My name is Tim. I'm an IoT Specialist Solutions Architect with Amazon Web Services. This is the fourth session that should hopefully complete your understanding of AWS IoT suite of services and help you get started and accelerate on your journey to producing IoT devices at scale. Previously, my colleagues Michael, Simith, and Kapil discuss with you a high-level overview of our IoT services, as well as how customers have achieved successful business outcomes leveraging AWS IoT. We discussed how to connect devices as well as deal with the constraints of the edge. In this presentation, we will dive into the impacts of scale for IoT workloads and what strategies you can implement to manage your fleets of devices. So let's dive right in. First, we'll do a brief review of the AWS IoT components. We'll then talk about security in more details. We'll cover managing fleets of devices, as well as how to onboard your devices successfully when in production. Finally, we'll discuss IoT analytics that enable you to make sense of the data from your devices, as well as cover two solutions we've made available for you to use today. Do also tune in to the following session, as we'll be running demos covering all of this. Since we introduced AWS IoT Core in 2015, we have been listening to our customers, and we have introduced numerous other services to complement our IoT Core functionality. We've added more device capabilities, as well as better management at the cloud level. At the center is the AWS IoT Core. It's the central communication service for IoT. There are 6 core functionalities. It's an MQTT message broker, allowing for publish and subscribe-based messaging on topics. It serves as an identity service and device gateway. All devices will identify themselves securely to the gateway, allowing support for MQTT connections, HTTPS, and WebSockets. Connections are encrypted using TLS 1.2, and authentication is achieved via X509 certificates. Its rules engine allows acting on the incoming data in real time and republishing or transferring the data to other AWS services. For example, storing the data in S3 buckets, passing it off to Elasticsearch, or sending the data to a Lambda function to execute some compute function on the data before passing it off to other serverless functions. The device registry allows to track all the devices connecting to the gateway, as well as query those devices based on attributes, allowing you to define groups of devices based on business needs. Finally, the device shadow, which is a virtual representation of the state of your devices in the cloud. Your devices report their state, your applications define what the desired state should be, and the service manages the delta, notifying your devices to change their states. The AWS IoT Core service allows for robust, scalable, and secure connections and data communications between your devices and the cloud. And in order for you to get started easily, we've provided SDKs for numerous programming languages, enabling robust connectivity for your chosen set of devices. And since we're talking about devices, we've also invested significantly to help our customers connect those devices. Even the low-power, very resource-constrained devices leveraging microcontroller-based architectures. For this, we introduced Amazon FreeRTOS last year. Amazon FreeRTOS is based off of the very popular free real-time operating system FreeRTOS for microcontrollers. The same real-time operating system that engineers have been leveraging for years in their electronic devices. Amazon FreeRTOS simplifies connecting your devices to the cloud. It supports AWS libraries for connecting locally as well as to the cloud. It implements the same security standards you need to connect to AWS IoT, and currently in beta, will support the over-the-air update capabilities of AWS IoT. And for those devices that are limited by the complexities of the edge, we introduced AWS Greengrass. Some devices just can't physically connect. There simply isn't any physical data connectivity possible in those locations. Or sometimes it's just too costly to connect all the devices and report all their data. In some cases, laws require that data stay on premises and be managed and crunched locally. For these reasons, AWS Greengrass is a great fit. It's software we provide that you can install on Linux-based hardware down to very small powered devices like Raspberry Pis, but up to much more powerful beasts, like, for example, the NVIDIA Jetson GPU-based hardware, or even full-fledged multi-core servers. It's a local MQTT broker, allowing for local devices to connect to it. You can trigger actions locally on Greengrass by deploying Lambda functions onto the device. The same Lambda functions you're accustomed to writing in the cloud can run on your device. It supports local device shadows, allowing your applications and Lambda functions to interact with the state of your devices without needing to connect to the cloud. It implements the same level of security as the AWS IoT Core with TLS 1.2 encryption and the usage of X509 certificates. Local resource access combined with machine learning inference allows you to create models that leverage local hardware GPUs, for example, for accelerated data calculation. Finally, with over-the-air updates and support for protocol adapters, AWS Greengrass is a perfect service for full-fledged capabilities of IoT at the edge. This summarizes very briefly how we are supporting all types of devices in the field for all types of workloads with AWS IoT. But that's only half of the story, because IoT isn't complete without data, and how to make sense of that data. And the AWS cloud is the perfect host for this data to make sense of it, act on it, and drive successful business outcomes. But before we dive into the cloud-based IoT services, I thought I'd take a couple minutes to discuss security. When we engage with our customers and we discuss security, I'll sometimes hear the following: "My system does not need security. The device is deemed too small, too insignificant, not powerful enough, so why would you invest in security?" Your system does need security. If you are connecting a sensor, collecting data, and making business decisions from that data, how can security not be a priority? Here's an example. We've been discussing IoT with a train operator recently. They also mentioned that their devices did not need security. The bathrooms in their trains are equipped with a sensor reporting the state of to the operations facility. When one or more bathrooms on a given train was in need of cleaning, that train would be placed into maintenance. So if security is not necessary and some malintended person hacked these sensors, he could effectively take down a whole train's operations for no reason. That could have significant impact on the business. Some other customers will tell us that security at this level is too expensive. Again, we challenge that assumption. At the BOM level, secure element chips at scale will cost less than 50 cents per device. And how much would you estimate the cost of fixing a device out in the field, as well as estimating the impact security flaws could have in the market for your brand value? This is why we announced at re:Invent last year the AWS IoT Device Defender, coming soon in 2018. The service will allow customers to maintain a solid security posture at a fleet level, from monitoring connectivity, certificates, identify anomalies, and get notified when improper behavior is detected. Thorough auditing against best practices of device security policies can be scheduled or run ad hoc. You will be able to monitor device behaviors. That behavior can be defined through security metrics as well as data from the devices. You can create your own device profile defining the expected device behavior. For example, defining from which IP address a given device is supposed to be connecting from. And you can compare your device metrics over expected behavior over time to monitor the device behavior over 24-hour periods, making sure your device is not deviating in its connectivity behavior. AWS IoT Device Defender will allow you to identify anomalies. You can blacklist and or whitelist behavior based on IP destinations and geolocalizations. Connection IPs or open ports on your devices, and on the metrics, you can define thresholds. Thresholds like number of active connections, number of open ports, number of outbound packets across all protocols per unit of time, number of outbound bytes across all protocols per unit of time, number of authorization failures within 24 hours, and message rate and size. Based on these metrics and thresholds, you can generate alerts. alerts from the anomalies in behavior based on the auditing. These alerts are connected into AWS services by sending them to the AWS IoT Console, to Amazon CloudWatch, and Amazon SNS, allowing your applications to access these alerts for further processing or automatic actions. You'll be able to review the historical and contextual information about your fleet when it fails an audit and when the behavior deviates from the expected state. The service provides recommended actions for you to view to minimize the impact of these security issues. AWS IoT Device Defender is a managed service, simplifying the maintenance of your security posture at the fleet level. Another best practice we recommend our customers follow is leveraging the use of secure element chips if possible. These are hardware security chips that cannot be tampered with. The purpose of these chips is to hold your device keys for you and cannot be read from. These chips perform cryptographic operations with the provided private key for that device. Since they're tamper-proof, your private keys cannot be extracted from the chip. From a high level, you place a chip on the electronic board that contains your key in hardware form. All your application has to do is interact with the chip without the need to know or access the key. The cryptographic operations necessary for the communication with AWS IoT is handled by the secure element chip itself. And as I mentioned before, at scale and large volumes, these chips can cost less than 50 cents a piece. They provide a fail-proof security measure for your devices, securing your workload in hardware form. One of the reasons we recommend this approach from a security perspective is in regards to the different encryption mechanisms available for you to store your keys. If, for example, you wanted to store your keys in some encrypted flash, it basically means your application can access those keys. Whilst your application is under your control, if a third party had means of executing code as part of your application, they in effect could have access to your keys. Using secure element chips guarantees that even your application can't access the keys. An example of this is this device. Now, we work with Tect, a company based out of Australia, to build these devices based off of the ESP32 chip from Espressif, and we added the microchip ECC508A secure element chip. We used this board at reInvent for numerous workshops, and it's actually been quite a hit. As you can see from this slide, the secure element chip is tiny on the PCB, and its benefit is huge in terms of securing access to that key on the device itself. Once loaded onto the secure element chip, my key is set up and cannot be extracted by an evil party, providing me with the highest level of security for my device when out in the field. And since the goal of this presentation is to explain how you would implement IoT workloads at scale, here's a high-level view of how you would get your device manufactured. Obviously, it starts with you. You would approach a secure element manufacturer as part of your BOM sourcing. If, for example, you wanted to use the ECC508A crypto chip, you would work directly with Microchip. And we can definitely help you with those conversations. Then, you would provide your own certificate authority to your chosen secure element chip manufacturer. The secure element manufacturer would then produce secure element chips for you in your chosen quantity. They would burn in the keys signed by your CA. Then they'll provide you with the data corresponding to the secure element chips that you've ordered, allowing you to track those keys. But you would not have access to the keys specifically. They would be baked into the chips themselves. Your third-party manufacturer, responsible for building out your final product, would source the different elements of your BOM and would start producing the finished device. They will receive the secure element chips in reels, ready to be soldered onto your PCB. All your third-party manufacturer receives is chips. It cannot read what's on those chips because they're tamper-proof and read-proof. For them, it's just another component they need to place onto your board. What you end up with is your final product, and you're ready to go. No complicated provisioning required for your device certificates. They are built into the device from a hardware perspective, directly out of production. Now that we've produced our devices, and especially at scale, we need to manage those devices. And for this, we've created AWS IoT Device Management service, which helps customers manage their fleet of devices more efficiently. AWS IoT Device Management allows you to provision your devices onto the platform, query and search your devices, monitor them, and update them at fleet scale. You can batch provision fleets of devices. You can define provisioning workflows to register device information such as metadata, certificates, policies for entire fleets. Definition of your devices in the cloud from thing, certificate to policies are represented in JSON templates. And you can register devices in bulk with simple API calls. You can track the provisioning progress and download reports for these tasks. And this doesn't only apply to new devices, you can also implement this for existing devices. AWS IoT Device Management supports real-time fleet indexing and search. You can query across different data sources on your whole device fleet in near real time. It currently maintains an index of 2 data sources, Thing Registry and Thing Shadows, which allow you to find devices within a fleet based on any combination of device attributes and states. For example, you could use the Device Management service to find all devices manufactured after 2013 with firmware version 1.2 that are connected to a charging station. And we'll be adding more data sources to the indexing, sources like connections, errors, or custom data sources. Another great functionality of AWS IoT Device Management is the ability to support over-the-air updates of your devices. Over-the-air updates allows you to push updates to your devices whilst they're out in the field, fix bugs, or improve functionality. You can receive notifications on the status of each device update to monitor your updates as they execute. You can target groups of devices to update in bulk, or pinpoint single devices to update, giving you very granular control over your fleet updating process. With such control over your fleet, you can control the blast radius of these updates. So AWS IoT Device Management adds very powerful functionalities for you to manage your fleet of devices at scale: monitoring, querying, updating, and provisioning. In terms of provisioning, let's look at a couple examples of different strategies you can implement for your devices. This list is in no way exhaustive, and you can customize your onboarding based on your unique requirements. Here, I'll cover pre-registration of your fleet, just-in-time provisioning, just-in-time registration, and one of our available solutions, open-sourced, the certificate vending machine. Pre-registration, whilst very simple to implement, does have some requirements in terms of your operations. Basically, you need to know everything about all your devices ahead of time. You describe all your things, certificates, and policies in JSON form, and leveraging AWS IoT Device Management, you trigger their provisioning in bulk. And you can organize, group them accordingly, waiting for the devices to effectively connect. And in some cases, you may end up provisioning thousands, millions of devices, and only having a certain percentage actually connecting in. Just-in-time provisioning solves for this and simplifies some of that process. And you don't need to know which devices are going to connect ahead of time. To illustrate this, here's how it works. At the center, we still have AWS IoT Core. You register your own certificate authority by providing AWS IoT Core your CA. You also provide it with a registration template. This template will define what you want to provision, thing, what policy, and what to do with the incoming certificate connection. Then, you distribute your devices and wait for them to connect. Your devices will connect to AWS IoT using the certificate you pre-created for them in manufacturing. For example, your devices are using the secure element chips discussed previously. At this stage, your devices have a certificate baked into them that are signed by your certificate authority. AWS IoT Core at this point only knows the CA. Your devices initiate their first connection to AWS IoT Core. The incoming connection is authorized, and the certificate making that connection gets checked against your custom CA. If the incoming certificate was signed by your custom CA, then it is one of your devices. The certificate is added to the AWS IoT Core and is given the pending activation state. This will trigger the provisioning process. Your pre-configured registration template gets executed. Effectively provisioning into AWS IoT Core the thing and attaching the certificate to that thing, as well as a policy to the certificate. Once the provisioning is done, you can choose to leave the certificate in pending activation state so that you can trigger other manual or automated tasks custom to your business logic, or automate simply activating the certificate. Once the certificate is active, data communication between your device and the AWS IoT Core is enabled. The connections are left open, and depending on the defined policy for your thing, you can publish and subscribe to topics of your choice. The process is very straightforward. Very simply, devices are manufactured with custom unique certificates that are checked belonging to you. Devices auto-register themselves onto the platform based on configurable templates for which you have complete control. Just-in-time registration is slightly different, effectively achieving almost the same thing. Devices auto-register themselves, but the actual provisioning of thing, policy, and certificate attachment is left under your complete control through the use of Lambda functions. Simply, you register your own custom CA. Devices which are given their own unique certificate connect to AWS IoT Core. Certificates are registered in pending activation state. And then lifecycle events are triggered on custom topics on which you can attach rules that will trigger Lambda functions. Within those Lambda functions, you can provision things, policies, attach certificates, change group structures, implement some custom business logic, etc. When done, you change the certificate to active and your devices are good to go. Now, whether pre-registration, just-in-time registration, or just-in-time provisioning, assume your device already has its own unique key when initiating their first connection. In some cases, your devices may not have that certificate, and you may want a process for having the devices download their certificate. For this scenario, we've open-sourced a solution called the Certificate Vending Machine. As the name suggests, it's a whole solution leveraging Lambda functions, DynamoDB, and API Gateway for a serverless certificate management system for your devices. Your devices have a unique identifier somehow, a serial number, a device unique MAC address, whatever you choose. Your device makes an API call hosted via AWS API Gateway, triggering a sequence of events via Lambda functions to provision a new certificate, register it in a DynamoDB table, and serving it back to your device. Once your device receives the certificate, it can then make its first connection with AWS IoT Core, where you can implement one of the three previous strategies. The certificate vending machine is available on our GitHub account for you to use today. I hope you now have a better understanding of different strategies available to you to onboard and manage your devices at scale. Now that your million devices are connecting successfully, reliably, and at scale to AWS IoT, we need to discuss data. IoT must serve your business needs and outcomes. Connectivity is only an enabler. Business outcomes will be driven from data. Where AWS IoT Core via the rules engines allows you to pass data to different services, we've recognized the need to be able to make sense of large volumes of data, run analytics on that data, and at scale. This is why we introduced AWS IoT Analytics, which is now in GA since April. IoT Analytics is a fully managed analytics service to easily analyze IoT data. First, you define an IoT analytics channel and select the data you want to collect, so you only store and analyze the data of interest. Captured data is enriched with device ID and timestamp in order to perform time series analytics. You then define an IoT analytics pipeline to process your data. Data transformations can be applied with conditional statements, filtering, and enrichment using external sources and AWS Lambda functions. After processing the data in the pipeline, the data is then stored in an IoT-optimized data store for analysis. You can then query your data with a built-in SQL query engine and you can create more sophisticated analytics via Jupyter Notebooks. Finally, you can visualize your data using Amazon QuickSight. IoT data journey starts with your channel. Data can come from multiple sources: IoT Core, Kinesis, S3, or custom sources via APIs. IoT Analytics being a managed service, you do not have to worry about scaling the service. It is managed for you. Once you've set up your channel or data source, you define a pipeline. There, you can filter messages for relevance on your analysis. You can transform the data via mathematical and conditional transformations. You can enrich the data with extra information, or you can trigger Lambda functions to custom pre-process the data to add more complex data structures to it. For example, adding geolocation data or weather information. Now that your data is being ingested and run through a pipeline, you store this data in an IoT Analytics data store, where you can store the raw and processed data. A fully managed data store, scalable by design, partitioned by time, supporting faster query response on time series data. The data store abstracts multiple database technologies via a single interface and allows you to manage data retention policies. From your data stores, you can then define data sets that are the result from queries on top of your data store. This allows feeding data to different clients, for example, mobile apps, reports, or QuickSight dashboards. Queries are achieved via standard SQL statements. You can run them ad hoc or scheduled, and you can visualize the data in QuickSight dashboards via the native QuickSight connector. Your data sets are then available via API, console downloads, or within Jupyter Notebooks for deeper analytics. Finally, IoT Analytics provides Jupyter Notebook capabilities, allowing you to build machine learning model notebooks, leveraging popular libraries such as scikit-learn and TensorFlow. We even offer pre-built notebook templates for common IoT use cases: predictive maintenance, anomaly detection, fleet segmentation, or forecasting. And to make it easier for you, the notebook capability is integrated within Amazon SageMaker, allowing you to use your SageMaker notebook instances to run your analytics. AWS IoT Analytics is a great managed service, allowing you to make sense of the data coming from your fleet. I hope this gives you a better view on how you can manage your fleet of IoT devices and data at scale. In the hope to give you even more understanding, let's go over two full-fledged IoT solutions we've made available to you to use today in your AWS accounts. You can find them on the AWS website and are ready to use today. The first one is our connected vehicle solution. Interestingly, this solution was designed before the availability of AWS IoT Analytics, and as such, showcases how you can make analytics on your data for anomaly detection, for example, using Amazon Kinesis services. The solution centers around devices you would generally place in vehicles. They'll connect to AWS IoT Core and have just-in-time registration flow using AWS Lambda. Then, multiple serverless applications will connect to AWS IoT via the rules engine to enable different business logic. On one end, we'll leverage Amazon Firehose to dump the raw data into S3, acting as our raw data lake. That flow will, via Amazon Kinesis Analytics, Kinesis Streams, Lambda, and DynamoDB, allow for anomaly detection in our data streams. 4 microservices will then serve via their own Lambda functions and DynamoDB tables, managing trip data for their vehicles, driver safety scores, trouble codes diagnostics, and location-based marketing. All of this enabled from AWS IoT Core, acting as the central data communication gateway. If you are looking into vehicle tracking and managing solutions, do have a look at the connected vehicle solution. It's available to you now, and the flexibility of AWS IoT and the rules engine will allow you to customize it for your needs. In some cases, you'll need real-time monitoring for your devices. To help with this, we've introduced the real-time IoT device monitoring solution. This solution leverages Amazon Kinesis services also to achieve near real-time dashboarding of your data. Your devices all connect to AWS IoT Core securely and at scale, and an IoT rule passes the data to Kinesis Firehose. From there, data gets stored into S3, processed, and Amazon Kinesis Data Analytics allows you to run specific queries on your data, passing the results to DynamoDB via Lambda function. And from there, you can display the information in near real time on a dashboard to which your customers authenticate to via Amazon Cognito. A simple enough architecture, but a great starting point for your dashboarding needs, leveraging Kinesis services. I hope this brief presentation gave you a better understanding of what you can implement today to manage your fleet of devices. If you are looking for more information and want to gain more confidence and hands-on experience with AWS, do have a look at the training content available to you now on the aws.training website. You can access the digital training content built by AWS experts, find information on how to attend our instructor-led classes by qualified AWS instructors, and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Then, validate your technical expertise on AWS and use practice exams to help you prepare for AWS certification. AWS also has a wide partner ecosystem to help you focus on your success and take full advantage of all the business benefits that AWS has to offer. To learn more about APN partners and find the right one that fits your needs, please visit the AWS APN booth at our showcase. Thank you for attending this session of AWS Innovate. We hope you found it interesting. Do provide us with your feedback and let us know how we can improve the event experience for you in the future. Thank you.